Any questions in the book? Anybody look at those? Is there any ones we haven't been over? I'm sorry? On 514? Number one, higher the gauge, smaller the wire, right? A. 2 is B, square millimeters.
C.
Yeah.
Where are we?
You said V square millimeters.
On the up
C
chapter.
square millimeters.
We're on 3 now.
Yeah, we're on 514, ways in the book. Question number 3. Use rating should be higher than the normal current for the circuit. B for 3. Which statements are true about wire terminals and connectors? A. Wire is called the lead. Metal end is the connector.
A for 5. Is it?
Rosencoya.
Rosencore, yes, for 5. Number 6. Lunar wire repair on an underhood wire which is going to be exposed to the weather. Deck A says use solder adhesive lined heat shrink tubing or a crimp and seal connector. Correct? Yes or no?
Yes.
Okay. Deck B says to solder it and use electrical tape. No. Do not use electrical tape. It does not work.
I thought I was on the wrong question at first. She said something about weather.
No, I just threw that in there. That's what they were getting at. That's why they put under the hood, because it's exposed to harsh environment. Fuse testing. Okay, says if the test light lights on both test points, the fuse is okay.
True.
Deck B says the fuse is defective, the test light lights on only one side of the fuse.
True.
Both of them, right? Okay. Many ground straps are uninsulated braided because of what?
Both A and C.
Yep. D is the correct response. What caused the fuse to blow? D. Orange conduit indicates a high voltage circuit.
D.
Right, okay. Wiring schematic circuit testing is what we're going to do next. Interpreting wiring schematics, explained in symbols, relay terminals, stuff like that. Yeah.
Does it show you different answers on your book?
There is no answers in my book.
I mean, like on
I have
your,
the same
like,
book you do.
Oh, 'cause you said A, high voltage. I was confused. Unless my shit's fucked up.
No, D, high voltage, yeah. No, there's no answers in my book.
Okay.
I have the same book you do. The only answers in my book are ones I mark in there, so, yeah, they're exactly the same. Okay. Let's see. Locating shorts, opens, resistance problems, in electrical circuits, determining the necessary action. Methods for locating a short, procedure, troubleshoot electrical problems. Terminology, a wiring schematic, sometimes called a diagram, shows electrical components. Wiring using symbols, lines, represents components and wiring. All circuit schematics include power side of the wiring, splices, connectors, wire size, wire color, trace color, circuit number, electrical components, ground path, fuses and switches. Okay, let's see here. This guy right here is a good example. Since there's only so many colors, what do they do to identify wires so they don't all have the same 4 or 5, 6, 7, 8, maybe 9, 10 different colors?
Different markings.
They put this little thing
slash
called a
between.
tracer. like this right here.
The markings.
That's what that means.
Let me see.
Trace color.
Trace color.
This happens to be in like a circular motion. Some of them are just a line on the
Oh.
wire. This is obviously just a solid color, but that's how they do that, okay? And on the wiring schematic, it's gonna say, let's say the wire is brown with a black tracer. That's what it's gonna look like. Okay? That's how they're gonna describe it. Brown with black. This is the wire color, this is the tracer, the second one, okay?
Question, do you, well, in the test, is there any questions on, what color to, what it should hold, like how many ounces it hold?
No.
Okay, good. Just wanna make sure so I can memorize it.
Yeah, all right. The first color of the abbreviation, just like I showed you a minute ago, is the color of the wire. The second one, if it's mentioned, is the tracer color. So if the wire was orange with a white, they might do this. That means the wire is orange, and it's gonna have a white stripe on it, okay? Okay. It's also gonna give you the wire size. Wire size is shown on all schematics in either AWG or square millimeters. Couple examples here. Center wire solid color, meaning that it has no other identifying stripe or color, so it's just going to be labeled blue, and they're going to abbreviate that BLU. The others would be labeled blue with a white, as you can see, blue with a white tracer of some sort. That way you can identify the wires. There's the abbreviations and the colors. They should be pretty obvious. There's nothing tricky about that. I mean, if you look at the abbreviation, it's pretty obvious what the color is, okay? Okay, typical wiring diagram. Notice that the wire color changes at C210. The 0.8 represents the metric size of the wire in square millimeters. This is a rear marker light. As the wire comes through the harness, there's a connector right here. This is schematic symbol for the connector, okay? The wire changes colors here. So if you were going to check this to see if you had power at this bulb here, this is the wire you would look for. The purple with a white stripe. And it's going to be 0.8 square millimeters, give you an idea of how big it is. These are some normal electrical symbols you'll see in schematics and circuit diagrams.
Do we need to know all these symbols?
No, just basic ones. You're going to need to know what a ground looks like, a connector looks like, a splice, that kind of stuff, but I'll show you which ones you need to know. Two ways wire size can be displayed on a schematic, obviously metric and standard, which we talked about. The plates of a battery are represented by long and short lines. Remember when drawing schematics here, the little circuit, draw it like this. This just represents the battery, right? It's gonna have one long line, one short line, kind of like that. And then it'll have like, the voltage for the battery or whatever. Electrical wiring is shown as straight lines with a few numbers or letters to indicate wire size. Circuit number, wire color, splices, connectors, location of it. They also help you out with that. All of the connectors and things like that all are coded with numbers to tell you what part of the car it's located in. Electrical components have their own unique symbols for the basic function or parts. Electric motor will be shown as a circle with a letter M in the middle. Sometimes it'll look like that. Sometimes it'll look like that. The wires coming off, okay? Symbol for electric motor. There should be a symbol for electric motor in here, no?
Oh,
This is, yeah, this,
It's, 519
Oh, 19.
at the top.
Okay, thank you.
mhm, yeah. Not all of these are in here, there's a lot of them, that's just a few. Okay, resistors, capacitors, electrically heated unit. A resistor is a symbol like this, we've seen this before when we did the electrical. Capacitor is one of the lines curved indicates that capacitor being used as polarity, which we'll get to when we do capacitor. Electrically heated unit is going to look like a just a grid kind of. Okay. Make a note of this. You're going to need to know this. Okay? Going to be on the test.
Box components.
A solid line around a component means you're looking at the entire component on the schematic. If it's a dotted line or a dashed line, that means it's part of the component. You're going to need to know this too. All switches are shown in the schematic in their normally open position, or their normal position, before they're acted on, meaning before a switch is flipped, a button is pushed, or whatever. In their normal position, okay? A box drawn with dashed lines in a wiring schematic indicates what?
Say that one more time.
A box drawn with a dashed line in a schematic means what?
Part of a component.
The box entire component.
If you see this in a schematic and you're looking at something in here, you're not looking at the whole thing. They're only
Part of
showing
it.
you what you asked to see when you looked for that schematic, okay? Means it's part of another component. If it's got a solid line around it, you're looking at the whole thing, okay? We'll see some examples of that. Okay, in this typical connector, note that the positive end is usually the female connector. Why is that?
Note that the positive she's receiving.
Two component. Why is that?
The arrow's pointing that way and it's receiving.
Well, it's not, these aren't arrows, this just indicates a connector. This is a schematic symbol for a connector. That means two wires are connected there. The reason they do that is when you unplug this, the power side is less likely to touch something and short out because it's the female connector. It's the female side of the connector, okay? Okay. Symbol for battery just looks like plates, usually lines. Sometimes it'll have a positive and negative on it. Ground symbols, you're going to have to know these. This is one of the symbols that you have to know. Earth ground, chassis ground, they're both grounds, all right? Okay, at the top of this, wire from the ignition switch is attached to terminal B of connector C2. The wire is 0.5 square millimeters, or 20 gauge. It's yellow, circuit number is 5. Wire enters the connector at C202 at terminal B3. I'm going to tell you everything you want to know
We're
about
on
it.
page 517.
Really?
Yeah, it keeps bouncing back and forth.
Yeah, where are, like, you, I'm
Yeah,
lost.
I am too. It keeps
completely
going
lost
back
in
and
this
forth.
chapter.
I'm on 520,
I'm lost.
517.
the pictures bounce around, like we're over here,
Yeah,
and
this,
over here.
this doesn't follow the book exactly,
Ah,
okay? So, sometimes you'll, that'll happen, okay? The circuit number is 5, the terminal is B3. Shows you the wire size, the wire color, okay? Yellow wire, that's the size, that's the connector, that's the circuit number. This is connector C101. When we get to that, I'll show you. Electrical symbol for the motor, sometimes it'll have the M, sometimes it won't, okay? A splice looks like that. That means these wires are electrically connected. It means they're touching each other, okay? This means the wires are not electrically connected. That means these wires just pass over each other in the schematic, okay? They're not actually connected. Does that make sense? Okay? Your connectors, your grounds, your splices, all of those are numbered. If the connector or splice or whatever has a number from 100 to 199, it's going to be under the hood. 200 to 299 is going to be under the dash. 300 to 399 passenger compartment. 400 to 499 is going to be in the trunk. That way it helps you to know where the things are that you're looking at. Right?
Yep.
Okay. Ground for the battery is labeled G305, G meaning ground. 305 meaning where is it at? If you were looking for, if you thought you had a bad ground at G305, where would you find this?
passenger compartment.
In the passenger compartment, right? Okay. Bulbs, lamps, schematic symbol for those. Motor again. Resistor, variable resistor, and then the 3-wire potentiometer on the bottom. Variable resistor, or this would be like the rheostat we talked about before.
So I have a quick question.
Yep.
So where do you find this symbols like indication in the car?
Where do you find the symbols?
Like on the owner's manual?
On the schematics.
No, I don't think it would be in the car. You'd probably have to look up a schematic for something specific.
Oh,
On the computer.
okay, so,
Yeah, these wouldn't be in the car. That's for like a wiring schematic.
yeah,
So if you're
you,
looking
you,
for something
you
specific,
you would actually have to look up a wiring schematic for something to see
No,
that.
I'm talking about the numbers, like maybe 100 to 190.
But where would you find the numbers?
Uh-huh. To know where exactly to go.
Would that be a
whether it's
scan
under
tool?
the wood or whatever.
Okay, let me go back here.
Make the noise, you giver.
Okay, you're gonna find the number. Let's say you were looking at this schematic and you saw this number.
Yeah.
Here's the number on the schematic. And then you're gonna know this is a connector. That's what the C is for. 202. And it's going to be
Under the dash.
somewhere in here.
Oh, okay. Is it the same on? every
Yeah,
car?
uh-huh, yep,
Oh, okay.
yep, yep.
Now
Okay.
you trying to get that S550 fixed for me?
I'm sorry?
I was talking to him.
Oh,
I thought he was trying to get his S550 ready for me.
okay. This is a symbol for a capacitor. If it has the curved line, that just means it's being used as polarity. That means it matters which way the terminals go. Grid symbol. This is the one I'm telling you. Dash line indicates a portion or a part of the component. Solid line means you're looking at the entire component. This means that the component is case grounded. You see a symbol, ground symbol on this? Okay? Switches. These are different types of switches. Symbol for them. These are single pole, single throw, single pole, double throw. All that means is that the switch has two positions that it can be in other than just on and off. Can you see the difference between these two?
Yeah.
Okay, this says single pole, single throw, right? That means you have a single pole and it only has a single throw. It's not doing anything here, right? It only does something until when you hit this switch and then it connects it to this wire, right? This one has two positions it can be in, meaning it's gonna do something here and it's gonna do something here. This one's gonna do nothing here, okay? That's why this is a single pole, double throw, okay? That's what that means.
You think something like that would be for like a window lock? You know, you can keep it in an unlocked spot and a lock position.
Mhm. Then you have the double, does the same thing, it's just that you have two poles,
Okay.
okay? Same thing here. Okay, this is a symbol for a normally open momentary switch. Or a button is normally what you would call it, say like your horn button, okay? That's what it would be like. This is a wire, this is a wire, right? This is your power wire, this probably goes to the horn, let's say. You push the button, it connects the two. It's a momentary switch, okay? A horn, your horn button's a good example of a momentary switch, right? It only works when you have your hand on it, right, or your finger on it, right? It's not a switch, you don't flip your switch, you don't flip the switch to honk your horn, right? That would be kind of rude, wouldn't it? You could just drive around with your horn blaring. Okay. Same thing, only what's the difference?
Normally closed, momentary
This is a
switch.
normally closed switch. Remember, schematic symbols are always drawn in their normal position. To be on the test. You got us, Terrence? You alive? You sure? Okay. How do you know this is a normally closed switch?
It's connecting.
Connected, closed.
Because these are already connected, right? It's drawn in its normal position. So if this was a button or switch or whatever, when you pushed it, it would open that circuit. Right?
Yeah, but same thing with the horn.
Opposite of this one, right? There's nothing going on here until you push the button, flip that switch, whatever, right? Okay. They're gonna go through a bunch of schematics here. They're really the only thing you need to know. Let's see, which one of these are in the book, probably easier to see.
521.
Okay. So at the very top of 521, you will see at the top, normally that's where the power comes from, okay? So the power is usually drawn at the top of the schematic and then they work their way down. You can see the wire colors are there, the circuit numbers there, splices there, everything to identify the wires is there. Okay. Relay terminals, there's gonna be something about relay terminals. This is something that is common pretty much to all cars. Okay, as far as relay terminals go, the way they're numbered, the way they work. We'll look at a couple of these also. This is a normal relay. I've got the cover off of it so you can see what goes on here. We'll make this thing work and see what it does, okay? Normal relay terminals, 30, 87, 85, 86, and if it's got a fifth terminal, it's going to be 87A. 85 and 86 are the relay coil. This is what needs to have power and ground in order for the relay to work. Relay is just an electromagnetic switch, okay?
Okay, so wait a minute, so the terminal is 30, the contact points to complete. You said the terminal was 86 and 87?
85 and 86 are the relay coil,
Oh,
which is your electromagnet,
Oh, oh. I misheard
Okay.
you. I got you.
okay? Tell you what, so this is easier to understand. Let's do this. Come stretch your legs for a minute, come up here. We're gonna do this real quick. I'll show you exactly what goes on here, okay? Okay. The relay is going to be numbered. See the terminal numbers on the bottom of this? Come on. It's not gonna do you any good to be back there. Look at the bottom of the relay. Can you read those numbers? Tell me where 85 and 86 are. Can you tell?
85, 86.
Okay, look this up. Look 1 to 85, 1 to 86.
Is there a certain way to do that, or does it matter?
Doesn't matter. Okay? Hold it like this. And I'm going to put the power to it, okay? What happened?
It's moving in and out.
See this arm right here? Look at this side of the relay. Watch the arm.
That's off and that's on.
Mm-hmm. So what that's doing is it's connecting terminals 30 and 87. It's just an electromagnetic switch.
So what if you put it somewhere else? It's not gonna work, right?
No.
It only has to be
This
at the
is the relay
86.
coil. That's why I was
Okay.
telling you. Terminals 85 and 86 are the relay coil. Okay?
So if you put it anywhere else, it won't work, and that's how you know it's wrong.
Mm-hmm. Okay? So that's your two terminals that actually cause the relay to work, see? Okay? So what happens is when these contacts close, it connects terminals 30 and 87. So you would have power here and you would be sending it to whatever device you're operating from this terminal.
Oh,
So as soon as the relay
okay.
engages, it controls a device, okay?
Okay, so that's the input and then that's the output.
Yeah, pretty much.
Okay.
So while we're here, test light, okay? Negative to negative, right? This is gonna be your positive. This is actually kind of not a basic test light. This is little bit better test light. See, it lights up red, right? We got power to it. It even gives you a voltage. It's got a voltage display on it. Okay? What does it say?
13.
What's this supplying?
13.
Pretty accurate, right? Okay, so let's do this. Let's look it up backwards. Now what happens?
It's green.
And
Logic.
it went negative.
It's a logic probe.
And
It's hooked up backwards now. Turned green.
And it went to
And
negative.
it tells you that the polarity is reversed, right? You got a negative there, right? This is the difference between a basic test light and a logic probe, okay? So if you were checking for a ground, you would put this on the positive battery terminal and then just use this to check for a good ground, okay? Obviously, other way around if you were checking for power, okay?
Yep.
Okay. All right. So, better understand what a relay does, right?
This one.
Probably,
think
yeah,
so.
yeah, okay. We'll go fix that. Right before lunch, we'll go fix your car, how about that? We'll go out on a little field trip and fix your car.
If we get through this first, we have to get through this.
We'll get through it. Okay, spike control, all this is some relays will have a diode across the terminals to control voltage spikes. When an electromagnetic field collapses, it can cause a voltage spike. All that does is just route it back into the relay so it doesn't damage delicate electronic components. This is what we just saw in action, right? Our relay coil, right? We put power to 85 and 86, right? Power on one side, ground on the other. It doesn't matter which one is which, okay? As soon as we did that, what happened?
Switch.
This is that movable arm that you saw moving, okay? As soon as we put power here, this went to here, right? It went from 30 to 87. What it did is it connected these two terminals. Okay? So I'll give you an idea of what a relay would operate like, okay? Normally you would have constant battery power here on terminal 30. But it's not doing anything, it's just sitting there, right? You could have, let's say you have a key on battery power here. Okay, so as soon as you turn the ignition key on, you have power here too. But nothing's happening until this wire gets grounded, right? You got
Say
that?
one more time.
We put power and ground to 30 or to 86 and 87, right? Or 85 and 86, right?
Mm-hmm.
So we put power on one and the ground on the other,
Mhm.
right? So if this relay was in your car, let's say operating something, you would have battery power all the time right here. This is your main battery power, okay? This would be like a key on power. You turn the ignition key on, now you have power here. So the relay is ready to go.
Okay.
All it needs is a ground. A lot of times your PCM will supply the ground. When it wants something to operate, it'll say, okay, let's ground this wire. And as soon as it does, this relay contact moves to here, and then it sends that power to whatever it's working. Let's say it's a fan. Okay, and then the fan comes on. Okay?
So the power is constantly flowing, it just does not.
Yeah, it's just not going anywhere.
Connect
Yeah,
until
it's-
you connect it.
Yeah, it's just sitting there doing nothing. So what it's doing is it's sending the power here once this relay coil is grounded. You have that electromagnetic pulls that arm toward it. Becomes an electromagnet. Okay?
If you were like if I was actively doing this while you were explaining it to me, I'd pick it up in seconds. But sitting here.
So maybe what we'll do later is I will hook up like a light bulb to that relay or something like that. And when we energize the relay, you'll see the light come on to actually see it work, okay? All right. This is exactly what we just saw. Here's our 85 and 86, right? We put power to one, grounded the other with the other terminal, right? And what happened? Created an electromagnetic field here, right? Which pulled this arm down here. And when it did that, it connected this terminal to this terminal.
Yeah. Yep.
Yep.
You need to be looking up here if you're going to understand this, okay? You got that, right? You'll get a lot more out of the class if you're paying attention, okay? I promise. Does this make sense? This is what we just saw, okay? Another view of the same thing. Terminals 85 and 86 are the relay coil. 30 and 87 are your contact points. Okay? When you have this coil powered up, pulls this arm down and connects these two terminals, okay? A lot of times the relay will have the schematic for it drawn right on the relay, but again, this is common, okay? And your schematic symbols, this is a normally open relay, normally closed relay. Should be pretty obvious by looking at this, okay? And the way it's drawn in the schematic is the way it normally is. All right, typical horn circuit. Notice the relay contacts supply the heavy current to operate the horn when the horn switch simply completes a low current circuit to ground, causing the relay contacts to close. So basic horn circuit. Your power at the top, right, when you're looking at the schematic, through the fuse first, right, you gotta have circuit protection first, right? So what happens? Terminal 85 or 86, whichever one, doesn't matter, has power right here, right? Your horn switch becomes the ground, okay? When you push your horn button, all it does is ground the wire. If it grounds this wire, then the relay operates, right?
Pushing the horn just is basically flipping the switch. You're just making that connection.
Momentary.
All a horn switch does when you push the button, all it does is ground a wire to the horn relay.
Yeah,
That's all it
to make
does.
it so that's where
It
you-
grounds that terminal, either 85 or 86.
Yeah.
And when it does that, it pulls this arm down to here, it sends power to the horn, and the horn works.
Yeah.
Okay?
Is there a wire for like, well obviously there is because the wire has to connect to the brake lights, but is there like a wire up front of the vehicle that like, you know, corresponds to the brakes?
To the brakes?
Yeah.
Probably not.
Because I seen a video, it's random, but I seen a video, somebody connected the wire for the horn to brakes, and it's so like every time this buddy hit his brakes in traffic, it honked. Like, is there like a solenoid or something, or?
You could do that.
Okay, like, how would that happen? Like, how would that work?
All you would have to do is take the wire from your brake light switch that goes back to the lights, that powers the lights, and just tap that into this wire right here.
Okay.
So as soon as the brake light's got power, the horn would honk.
Okay.
Yeah, you could do that. It'd be actually really simple.
Okay.
So if your horn doesn't work, either it's a fuse or the horn.
Okay, good question. If your horn doesn't work, first thing you're gonna do, take your test light and go, well, I got power on both sides of the fuse. The fuse is good, it's not the fuse. Then you would check, see if the horn relay was good. If the horn relay is good, then this switch is either bad, the horn itself is bad, or a wire connector, something, okay? Bad connection, something like that, okay?
Because my friend's mom's car's horn doesn't work when you click on it. I'm gonna tell them either it's a fuse,
Yeah.
horn.
Yep, or it could actually be in the steering wheel, the horn contact in the steering wheel itself, yeah.
Something
Okay.
not connected, basically.
Okay. When the relay or solenoid coil current is turned on, energy stored in the coil flows through the clamping diode, effectively reduces voltage spike. We're just talking, see this little diode schematic here across the relay coil? That's just a despiking diode or despiking resistor, something like that. It avoids the voltage spikes that would damage a component, okay? This is a schematic symbol for a transistor. Transistors can be either low side drivers or high side drivers, and you know how you tell? Where does this leg go? Is that power or ground? Okay, so basically a transistor is just an electronic switch, okay? So when this transistor gets turned on, it supplies the ground to this relay coil. Just like I told you a minute ago when I did that drawing, you already got power on one side, right? What's gonna supply the ground to operate this relay? A transistor inside the computer, PCM, okay? It could have a resistor instead of a diode for a despiking device. Locating an open circuit. Typical procedure for finding an open circuit, visual inspection. Get the schematic printed out, check everything that does and does not work. Check to make sure you got good voltage there, fuse, that kind of stuff. When diagnosing an electrical problem that affects more than one component or system, check the schematic for a common power source or a common ground. Okay? Example, all of those things could be on the same circuit. That's why it says check to see what does and doesn't work. Okay, that'll help you identify what's going on. Okay, this is a good example of, let's say you wanted to add something to your car, some electrical device or component or something like that, okay? Let's say, since you don't have a car, we'll use your Camaro anyway. Let's say you wanted to add something to your car, some sort of electrical. Or I take that back. Let's say you had a truck. This will be a better example. Let's say you had a truck and you want to put a light bar on it. Okay? Those like those guys use for off-road. You see big light bars on top of trucks, right? Let's say you wanted to add one of those to your truck. Okay? This is how you would do it. Always, always, always put a relay in the circuit, okay? You cannot just add lights to a circuit. You're gonna melt wires, you're gonna overheat it, you're gonna blow fuses. Put a relay in there.
Does it come with the relay when you buy the bar?
I'm sorry?
So usually when you buy the light bar for your truck, does it come with a relay? Does it come with like?
It could. It could come with one.
Depending on where you buy it
You could buy a
from.
relay and a connector, just do it yourself.
Depending on where you buy it from, like if you were to buy it from a company, like a straight company, most of the time they come with everything that you would need, like brackets, any type of adhesive or whatever, connectors, wires, etc., etc. But if you were to just buy a bar itself off of like Amazon or something like that, it won't come with anything.
All right, we're talking about electrical systems and components. You guys wanna see something crazy? Toyota. I have a video and picture. This guy did this to his car, and it's a hybrid. You guys, I took a video, you guys gotta see it. This is crazy.
Transformers?
I didn't do that thing. Oh, there you go. And let me rewind it. How do you rewind it?
The slide, tap the bottom or yeah, right there, like that. And slide right.
That right? Look, I don't even know how to use it.
Don't even know how to use it. So what's going on here?
This is a hybrid. This is a Toyota hybrid.
You put that on the front, is that the front of the
Look
car?
at the whole car. Look at the whole.
And that came to the shop?
And that came into the shop on Friday.
Bullshit. Looks like a bunch of lights.
You don't know. It's a good robot.
That looks like a light.
Look, no, there's more. The inside looks like.
That's some crazy.
Wait a second, no. Hell no, wait a second. Is that the radiator sitting down on the ground?
No.
Right there, that looks like a radiator hanging down, face down. Oh, hell no.
Dude,
There's tape everywhere.
it's a hybrid. And
Wires
everybody's
everywhere.
everywhere. And everybody's like, how did he do, and it's a hybrid. He did this.
How do you see out the front of the car?
Crazy.
There's fucking zip ties on the wires and everything. What is that covering the engine? He's covering the engine with plastic Tupperware lids. Oh my god.
Is that illegal?
The front could be illegal.
Wait, you guys didn't see
All
the
the stickers?
inside.
Oh, you got the inside?
No, Listen, this is a 2-minute video. There's an inside, guys.
What kind of
There's-
car is it?
It's a something.
This is something.
It's a something. It's the, you gotta see the inside.
VGK. VGK. The hell is VGK?
I don't
Tape
know.
all over the hood?
It's crazy. And it's,
The original hybrid or that car is a hybrid?
the car is a
I don't
hybrid.
watch sports. I don't even watch TV.
Okay, well, that's what it is.
Oh, you try to build like a car from a show or something?
I don't know.
I think
Wait
it-
till
oh
look
my
at the
God.
inside. This is the inside.
Yeah.
Oh, hell no. No, that's gotta be a violation, bro. How are you seeing out of your car?
That's
Either
nuts.
This guy's either a massive hoarder or he actually thinks this looks cool. He has a pocket on all that shit with a bunch of pens in it.
He's probably installed a microwave in there.
I don't think that's a living condition. I think there's a rug in the back.
Oh, my God.
I'm telling you, you're talking about electrical in this case.
What is that hanging off the exhaust?
I don't know.
Is that a monkey mask hanging off the exhaust?
But this, like, so, like, when you're talking about this, it's popping to my
He has
head.
a shield on his fucking.
How was it pop, like, and this is a hybrid. So what would he have had to do? He would have to be an engineer in order to do this, right?
No engineer would do no bullshit like that.
No, but
I have no idea what
That
that
is
is.
YouTube videos and too much.
That's
curiosity.
weird stuff.
That's
Yeah.
exactly what that is.
So this is what he did, Ron. This
Oh,
is the,
nah.
this is like,
I'm not gonna lie. If he pulled up to the dealership, I'm fighting. That's crazy. You're not gonna make me work on your car.
like that's
Take it
the
somewhere else.
battery, that's over the battery and everything.
Wow. Okay, well, that was exciting. Okay, anyway. What are you looking at here? Existing light circuit. That means this already it exists in the car. This right here, right? This bulb for whatever it is, okay? Maybe it's 5 bulbs, who knows, whatever. You wanted to add these guys, okay? You're gonna put a relay in there, and you're gonna have, when this circuit is operational, these will be too. Okay? Because what it's doing, as soon as this gets power to this circuit, it's gonna energize this relay, and it's going to light these extra lights, or whatever you have to put on your car, but it's gonna do it with the relay. You've got to have the relay, okay? But that's how you would add something to your car the right way.
Okay.
Okay? All right, troubleshooting, backup lights are inoperative, just check everything does and doesn't work. We talked about that before. Make sure the fuses are good, make sure the bulb is good, make sure the sockets are good. Sometimes the bulb sockets are bad. Locating a short, there's a lot of different ways to do that. We're not gonna go through all of those. Yeah.
You know what rock lights are?
Who?
Rock lights?
No.
They're like,
The side of the cars?
kind of, but on like bigger trucks, like when they get lift kits and whatnot, they put little light bulbs on the inside of their wheel well.
I've seen that.
What's it called? Like, is that like the same way? Like, cause they usually have like 4 or 5 of them in each wheel well. So like, just for example, there's 20 separate light bulbs. Do they have to have like 20 different relays,
Nope.
or so
Nope.
it's just like one
Yep,
relay?
one will do the whole thing.
Oh, okay, cool.
Yep.
Cause they're not big bulbs; they're tiny bulbs,
Yeah.
but they're just pretty.
And if they're LEDs, they don't draw much current anyway, so, yeah. One,
Okay.
one relay will do it, yeah. And you could hook it up to where it would come on with your normal lights, or you can put on a separate switch where you turn them on
Yeah.
individually, if you wanted to.
Okay. Most of the ones I've seen, they just turn on as soon as you turn the car on.
Yeah, yeah.
Okay.
When troubleshooting any electronic component or electrical component, identify the following, makes it easier. For a device to work, it obviously has to have a power to ground. If there's no power, it's not gonna work, right? If there's no ground, it's not gonna work. Any electrical device has to have a power and a ground in order for it to work. You saw that with the relay, right? Unless we connected both of those wires, one was a power, one was a ground, that relay wasn't gonna work, right? Everything has to have a power and a ground, okay? If the fuse blows immediately, you have a grounded power side wire. If there's power on both sides of a device, an open ground is indicated. We've been through all of that before as far as how to diagnose something. All right.
Anti-static spray.
Static spray. Sometimes people would complain about that. They would get shocked when they would get in their car from scooting across the street, you get the static electricity, and then they'd touch something in their car and shock them. They did make anti-static spray for that. I will let you know if there's any test questions on here, okay? I know we have to go through this minute quickly, so make sure you get the information you absolutely have to have.
We have 2 more chapters after this one, right?
Yep, we do. But one of them's quick, it's just magnetism, electromagnetism. The other one's on capacitors, they'll go fast. We'll have time to do them after lunch, I'm sure.
Question on 5, can't it be everything?
On 5, wiring diagram F110 with a .8. Brown, black means what? S means splice.
Under the hood. And 1110 is under the hood. A connector with .8 square millimeter wire. And then C is splice a brown black stripe, wire size 0.8 square millimeters, 18 gauge. And then both A and B. A and B could be correct, but also, shouldn't C also be correct?
Brown with the black. Right, wire size being 8 square millimeters, 18 AWG. Connector, no, it's not a connector, it can't be B. Can't be A and B because
Okay.
that would include the fact that it's a connector and it's not.
Okay.
The S being splice, so the only correct answer would be the one that says splice, which is C.
Gotcha.
A says spliced too.
I'm sorry?
Letter A says spliced also.
But C would be more accurate
Mm.
because it describes a black stripe. It just says spliced under the hood.
Mhm.
Okay. My fault.
Yeah, and A is wrong because there's no circuit number on
Yeah.
S.8 brown black, yeah.
I guess I got under the hood and then the wire.
Yeah.
Bless your soul.
What text?
Hmm.
I'm on 10.
Female.
According to the text, what text?
On 517, in this typical connector, note that the positive terminal is usually the female connector. Right there.
Mhm.
All right, you ready?
Yup.
Okay. You wanna do all 10 of them again? How come?
Huh?
How come?
Um,
Not feeling confident?
nah.
This symbol in a wiring diagram indicates a female terminal A.
Okay, what'd you get for number 1, Terrence?
I got 8.
Okay, you were right. Okay.
Number 2. In a schematic, a wire is labeled 0.8 black/white. This wire is A.
Oh.
Letter A.
I got
B, black with, white with black stripe?
No. It's black with a white stripe. Does it matter?
That's confusing, right?
Yeah.
It's black with a white stripe because this is the wire color. The second one is the stripe, okay? So it's not B. So what could it be?
A.
A?
But probably not A either, right?
Not A either.
So it's neither.
neither.
Yep. Why is that? Because it would be 0.8 square millimeters, not 0.8 millimeters. It's not white with a black stripe, it's black with a white stripe. Okay?
Like a zebra.
All right. Which relay terminal is normally closed for, what's your name? Child, that's right.
What's your name?
I think 8, right?
D. Dog.
Oh, 87A is normally closed.
It's on page 522.
Really, on page, let me see,
522.
523. I wasn't sure about that
The
one.
top picture.
The picture is here.
The very top on the left. The 87A normally closed output.
Okay.
For number 4, I got A.
Okay, question number 4 is probably gonna show up on the test later, so
Is it correct?
I wanna think about
Yeah,
that.
it's the box
If
with
it's
the
got
lines.
dash lines around it, it is portion of the component, yeah. That is right.
What page was that, Joe, that you said?
522 at the top right, or top left.
The picture. Figure 4225.
Oh, now I see it, okay, thank you.
On a wiring diagram, we did this one already.
C.
You're not off the hook there, Terrence, you get the next question. That was C, right, for 5?
Yeah.
Okay.
This symbol in a wiring diagram indicates a nailed terminal.
Yep, okay.
This symbol in the wiring diagram indicates A.
A connector, yes.
Tiffany.
Tia.
What
8.
was 5?
C.
Might want to make a note of question number 8. Why?
Test.
Question number 8.
Yes, 2 technicians are discussing finding a short to ground using a test light. Tech A says that the test light connected in place of the fuse, and that's on page 526.
Would it like not light up because it's not working
In
right?
place of a fuse will light when the circuit that has the short is disconnected. B says that the test light should be connected to the positive and negative terminals of a battery during this test. I know A is right, if I read
That's
that
right.
correctly.
I don't think so.
If he uses that screwdriver looking thing, touch
It shouldn't light up if it's disconnected.
The
If you're
test
looking for
light
something
uses
specific.
test light. If there is a short circuit, current flows from the power side of the fuse holder through the test light and onto the ground
How are
through
you
a
gonna
short circuit.
test a fuse
And
if it's
the
disconnected?
test light lights. So that's why I said A.
Is
That's
it
why he
neither?
said A. He said it'll light when the short's disconnected. It's the other way around.
Is it neither?
Wait a minute.
Yeah, the fuse wouldn't light up if it's
If
disconnected.
there is a short.
The test light would light as long as the short was present.
And
You
you
got
can't-
power on one side and the short to ground on the other side instead of it going to whatever device.
This dog, right?
Yeah, neither.
Neither one of them are right,
Okay.
okay?
All right, I'm still confused on this one. What did I misunderstand?
I have
So
no idea.
a fuse, if it is disconnected, there's nothing giving
No
it
power,
power. There's
yeah.
nothing that's gonna light up.
Oh, hold on, I have to
Okay,
read it.
so, here's a fuse.
That's like taking a wall outlet, holding it in your
Right.
hand, and plugging in your phone charger.
This
see if
is
it charges.
to
It's not gonna do anything.
whatever
Oh,
device
little
it's powered,
light.
right? This is battery powered, okay? You take the fuse out, because the fuse blew, right? You put the test light terminal here, and the other one here. If this is short to the ground, the light's gonna be on. He says the circuit will light when it's short's disconnected. When the short's disconnected, the light will go out.
Yeah, no, I misread it. That's why I was reading the question
Okay.
over again.
Okay. And the other guy says you should connect the test light to the positive and negative terminals of the battery. What the hell's that gonna do?
Blow up.
All it's gonna do is light the test light. It's not gonna find the short. Okay?
Yeah, I completely misread that question.
They're both wrong. Okay, all switches are drawn how?
I'm not gonna lie, I thought I was gonna get a 8, but all switches illustrated in schematics are always shown in their normal position.
Yep.
Okay, good.
A for 9, in their normal position, whatever it happens to be, whether it's normally open or normally closed, doesn't matter. Schematic's gonna tell you what the normal state of it is.
Gotcha.
10. The positive side of a circuit usually uses what type of connector according to the text? Female?
Yeah.
Mm-hmm. Okay.
Oh, I'm bleeding.
What was number one?
Number 1, 8.
All right. Symbol indicates connector. Box on the dash line indicates portion of component. We did that one. We did that one. This guy's wrong. All switches are drawn in the normal position. We did that one. Okay. When testing a relay between terminals 30 and 87A with the relay turned off, there should be what? Low resistance, yes. Okay. That might see that one later too. Positive side of the circuit usually,
We did that one, female.
okay, right, okay. In this diagram, notation C202 indicates what?
Connector 202.
C202, what does this mean?
Connector, right?
Color. Oh,
Connector, see the connector? C202, that tells you where it is. And the wire colors, and the wire size. Okay, Tech A says a good relay should measure between 60 and 100 ohms across the coil terminals. Tech B says OL should be displayed on the ohm meter when touching 30 and 87. You can answer this question with a demonstration. Ohm test terminals 85 and 86. What's the first thing you gotta do?
Turn it on.
Put it to the ohm scale, you can measure ohms, right? Straight up, right? Omega symbol, okay. Let's put this guy here like this so you can kind of see it. So, check terminals 85 and 86. Hey, what you doing there, man? You ain't crashing in the classroom. Touch 1 to 85 and 1 to 86.
At the same time?
What's that? Same ones you did earlier. What does it say?
Okay.
Display's kind of messed up on that, but there you go.
076.
76, 76 and a half ohms. What did the question read? Good relay should measure between 60 and 100, does it?
Yeah.
Yes. So he's right, right?
He is right.
Now touch the other two, 30 and 87. What does the meter read?
0.
Oh, well, okay, they're both right, right? Okay, we proved it. Oh, well, meaning there's no connection between 30 and 87, right? There's a connection there when the relay closes, right? So if you had it on 30 and 87, and you close the relay contact manually with your finger, which you could do, you would see it have a connection there, okay, continuity. Okay, both of them are right. Number 9.
True.
A loose or broken ground wire can cause more than one component to malfunction.
Oh,
Yep.
wait. Actually, yeah,
Use
true.
a broken ground wire.
That's true.
Yeah, what if they share the same ground circuit? That's why it always says check everything that does and doesn't work, right? Okay. That is correct. And we did this one already.
Yep.
Okay. All right.
What do you get?
I told you that the question that said, what should you read when 30 and 87 or check the resistance should be low, right? Told you that was me on the question, that should be on your printed quiz. Okay. All right. Let's see if there's anything in the book we haven't gone over. I don't think we'll start the next chapter, maybe we'll just take one here early today. Okay. Did we do question 1? On a wire diagram, S110 with a 0.8 round black means, that's a different question, isn't it?
C.
I'm sorry?
Number 1.
Yeah, number 1 is what?
C.
C? A
Brown
splice?
with black stripe, yep.
Okay, yeah, black stripe, each per millimeter, yeah, okay.
You did?
Yep. Okay, where is C250 located?
B.
Under the dash, you can tell by the car with all the numbers on it, right? Back in the, all switches are shown in schematics in their normal position.
A.
A. 4. When a relay is being tested with an ohm meter, which two terminals should be touched to measure the coil resistance? Terrence just did that for us.
B.
85 and 86, yes.
5 and 86.
Was 6?
I'm sorry, 5 we did, right?
Yeah.
5 we demonstrated with the meter and the relay. It's both of them.
Yep. 6 is D.
The normally closed terminal, D, 87A. Tech A, then it says there's often more than one circuit being protected by each fuse. Yes or no? It doesn't say always. It just says oftentimes a fuse is protecting more than one circuit.
Yeah.
Okay, that is true. B says more than one circuit often shares a single ground connector.
That's true.
Of course it does, otherwise it'd be 10,000 wires on the car instead of 8,000. Right, all right. Finding a short, we did, right? They're both wrong. Short to ground can be located using a what?
Isn't it any of them?
Any of them, yep. And for an electrical device to operate, what must it have?
Power and ground. A.
Huh?
Relay system? Meter.
Power and ground.
Yeah, 10 is A. For any Electrical device to operate must have a power and ground. All it needs. All right.
Chapter 46 is like 2 pages.
Yeah, today the other ones are not, we'll get to them quickly after lunch. So let's just go ahead and break lunch now, but don't be late coming back. Let's be back at 20 after, okay? Still an hour, just different time, all right?
Okay.
Okay.